Awesome. So yeah, I hope the translation screen is working and you can all see my screen. So today I'm here to talk about well-architected practices for serverless applications, which essentially means everything from building your serverless application to scaling it, to monitoring it in production, to optimizing it, to really making it the best that it can be. And before we start, a quick intro to myself. So I am the CEO and co-founder of Dashboard. I've been in software development for, is this the right slide? Sorry. Okay, I think this is the right slide. So I've been in software development for over 14 years. I've been involved in the serverless community since 2016, Dashboard is the leading platform in serverless monitoring today, with over 4,000 developers using it every day to monitor their applications, to improve their applications, and to understand how basically the users are using their system. The product varies from between different use cases, and in this presentation today, I will try to give you an overview of all of the challenges that we have seen over the years and kind of how to think about building on serverless in a scalable way. So before we jump into that, why should you care about well-architected framework and kind of what it means? And in our opinion, and obviously this is from AWS as well, it allows you to build and iterate your products faster. It allows you to mitigate risks, to reduce risks, and gain confidence into your system. So you always know that your system is working and you've done the best that you can to keep it working. Also, being well architected enables you to make informed decisions about your application and the way you're developing your software. And it should also guide you to learn and to maintain best practices across your serverless infrastructure. So the well-architected framework consists out of kind of 3 different sections. The first one is the pillars, which we will go into in the next slide. Then there's this design principles, or kind of the way to architect and kind of the basic principles in which you should always be following. And then there's questions that you can ask yourself about your infrastructure, and then to evaluate if you are or are not well architected. So let's jump into the pillars. The well-architected framework consists of 5 pillars, which cover the entire spectrum of kind of the best practices and all you should be thinking about. The first one is operational excellence. We will go into each one of those pillars in a second, and then we'll look at some real-world challenges. The first one is the operational excellence. Then there's security, reliability, performance efficiency, and cost optimization. So those pillars have been divided into sections in the white paper. There's also, when you're looking at a serverless lens of the well-architected framework, you will be seeing specific sections and material around how to be, reliable in serverless applications and things like that. So the first one is the operational excellence pillar, and this basically means understanding the health and activity of the application. So gaining insight into the usage and how users experience your application, getting observability data like metrics, traces, logs, and getting alarms, getting notified of anything that might happen. And really having all of the data about your system available at all times, and having an understanding of kind of end-to-end view of your infrastructure. The second part is the security. So security is all about controlling access to the application, controlling access to the data, and controlling access to the assets as well that you have in your infrastructure. So those include identity and access management, detective controls, automating the best practices of security, and really protecting the data at the end of the day. The next we move on to performance efficiency. So when you're building and scaling cloud applications, you should be thinking about optimizing the performance continuously, using your resources effectively and efficiently, and maintaining that efficiency over time as well. It's not just that you once do it and then you're just efficient for the end of times. And yeah, you should be reviewing your infrastructure decisions on a like close basis. I think so this is actually, the performance efficiency is this slide. Actually, let's talk also about the reliability, which is this slide. Reliability is all about building resilience into the application and being able to recover from infrastructure or service disruptions quickly. So getting notifications, planning for unknowns, having recovery plans, and building recovery into the systems, and really being aware of all of the limits and weak points and things that can go wrong. So the well-architected framework pushes you towards that as well. And lastly, we have the cost optimization. So yeah, as you start to scale and get more users into the platform, get more scale, then cost optimization becomes quite important for the unit economics. And in serverless, this is also quite an interesting problem because you have so many moving pieces, so many different services, and it's hard to understand the cost of your entire infrastructure. So it's important to think about this early on and implement financial management, which essentially means having just the visibility and kind of continuous overview of where you're spending your money, measuring efficiency, I think it's obviously you shouldn't be spending money on undifferentiated heavy lifting, but this goes to, first of all, building stuff that already exists in AWS, and then hosting them maybe on EC2 while you can use some other service. So yeah, choose the right tools for the job and analyze continuously. So this was a quick intro into the well-architected. Now let's dive into the real-world challenges of serverless, and kind of when you start putting that knowledge into practice, what does it really mean for organizations? So we've, as I said, we worked with over 4,000, or we are working right now with over 4,000 serverless community members, and the biggest thing that really comes up all of the time is the observability use case. So, getting visibility at scale into your infrastructure, monitoring applications, troubleshooting serverless applications. And what happens often is that there's a lot of time going into debugging, troubleshooting, and trying to understand activity and why things failed, for example, or why a user didn't get the best experience with your application. And this is mainly to the vastness of data that you have in your infrastructure. If you think about it, you have, if you take an application of 100 resources, you have 5 or 6 different metrics for each resource. Then you have logs, you have tracing data. So that becomes really difficult to navigate. And on top of that, we've seen that failures can actually go unnoticed because it's hard to implement a wide enough alert coverage across your system. So you have functions, they can time out, or they can have code exceptions, as any kind of piece of code that you you write, and they can have all sorts of downstream failures as well. So getting the alarm coverage is a big thing for a lot of the users. And I think the fourth biggest one is maintaining the posture of your cloud infrastructure, like maintaining all of the best practices, being not wasting money anywhere, not having slow endpoints, or if you do, then being like having the ability to improve and to fix those. So those are the most common challenges that we've seen in the market today. So perhaps let's talk a little bit about how tooling can help, or what can you really expect to fix with tooling. There's obviously a lot of things that like no tool is going to help. You need to learn about the best practices, and you need to kind of develop the right processes inside of your engineering team. But so if you're scaling a serverless application, you have like some load already, then there are a lot of things you can actually automate and make better and reduce risks. So the first one is obviously the observability. So we believe heavily in centralization, and that is the most important thing for any serverless monitoring solution. So what happens in the cloud is you have tons of resources. You have logs for those resources, you have metrics somewhere, you have tracing data, the resources have configurations that change over time. So there's a lot of complexity and a lot of surface area that you need to cover. We are working heavily on this problem. This is the kind of core competency of Dashboard, but there's a lot of different tools out there that approach this problem in one way or another. If we go a little bit more kind of specific, then the other point is that really matters, like, and I think you need good tooling for this, is to reducing the time to discovery and understanding the root cause of the issue. So this means like having not just like having access to the data and being able to navigate it, but also having like continuous analysis on top of that data, if like that tells you when something is wrong. Like if you have a spike in the metrics somewhere, if you are experiencing a higher latency than usual, or if you have more failures than usual, or if just like one user even gets a bad experience in a really important part of your system. So you need to have the ability to get, to discover those stuff as quickly as possible. We also believe heavily in automation and abstraction. So serverless as a concept is all about automating and abstracting the underlying compute and the complexity. We believe that there's still quite a lot of heavy lifting and quite a lot of manual work in the observability side of the market, and kind of managing alarms and protecting yourself against security risks and operational risks, reliability risks. Tooling can also scan for performance and cost inefficiencies, and I think there's potential to kind of automate the auditing part of the process. So are you wasting money or being slow anywhere? That shouldn't be a human job as well. And I think most of all, tooling should eventually help you learn about your infrastructure and to learn what works and what doesn't, and really to make informed decisions on how to iterate on your product. So yeah, these are all pretty much the things that we are also focusing on. But yeah, I hope kind of that most of the teams in the future are actually using tooling to overcome those problems and not manual work. So the way we think about like the well-architectedness or achieving and being as well aligned with the best practices as possible is the 3-pillar approach. In the first, like the pillars are observability, failure and threat detection, and a continuous audit or insights engine that evaluates your infrastructure for like any kinds of problems or inefficiencies. So the first part is, getting everything into one place and, providing a single pane of glass for the entire cloud data, covering it all with alarms automatically, pre-built alarms that analyze logs and metrics. And then the third one is looking at all of the different best practices in the community, looking at the WellArchitected Framework white paper, and kind of common sense as well, to give you actionable insights on how to improve. So this is how we basically address all of the challenges mentioned above that are like real world customers struggle with. So we can take a look at all of those pillars individually for a second. So the one of the special things about us has always been that we don't require instrumentation of your Lambda functions or of your infrastructure. So Dashboard is the only service that only works by collecting all of the data from AWS automatically and giving you an end-to-end view and really analyzing that data on the fly, making it like available to navigate as quickly as possible, and yeah, breaking the silos down between logs, metrics, and traces. We also focus a lot on perceiving how the user experiences the service, not just like if you have a failure in your service, but also like how are the users actually using it, which features, which make microservices get used the most, what's kind of the health or the experience of the service for the customers, and also to enable the understanding of how changes impact the performance and the cost and the quality of your service. So this is the first pillar. The second pillar is the failure detection. So what we do here is, imagine all of the metrics in your CloudWatch, all of the logs in your CloudWatch logs, all of the tracing data in your X-ray, the configurations of your resources and the way they are tagged. So we actually, as we ingest that data in real time, in less than a minute of latency, we continuously evaluate every log line, every metric data point to detect failures. And most of the alarms that we have are actually pre-built as soon as you onboard or start using Dashboard. So there's no setup, and whatever service that you're using, you will start with pretty much a perfect coverage of all of the different failures that you might have. These checks are, by the way, also open sourced, so you can check them out in our website, and you can access them without ever signing up to Dashboard. There's a library, and you can read what we check and why we think those checks are necessary, and also how to fix them, how to go into AWS, or how to prevent them from happening. There's over 100 documents there at the moment that you can really kind of deep dive and educate yourself on what to look forward. Yeah, and that brings us to the well-architected rules. So those aren't just alarms anymore, but those are actually like evaluations of the state of your infrastructure, the configuration, the way your services work together, and like the security aspects of different resources. If anything is abandoned, if it's wasting your money, or it could be improved in terms of the performance, with like actionable ways to improve as well. as kind of a closing note, I will walk you through the the demo as well. I will show you how it feels like. If you're considering the monitoring service for your serverless infrastructure, you should be thinking about three things. You need to increase the reliability and the speed of which your team is able to iterate, which means like understanding how the system works. The other part is focusing more on the customers. So taking away the burden from developers that they need to continuously look at like different data in your application and like have to build their own monitoring solution or work with the monitoring. So, build alarms, manage alarms, those kinds of things. And I think the third part is, how to align yourself with the best practices of the industry and how to you enforce team-wide learning of the best ways to do things. So this is the end of the presentation. I'm happy to take questions at like right now or later as well, but I would be also happy to give you a quick walkthrough of the product. So as I mentioned, the setup takes 2 minutes. You just deploy one CloudFormation template to your AWS, and then everything starts happening magically, which means you get a view of like the health and the cost and kind of everything, all of the active parts of your application in one dashboard. You can go into the inventory, so you can look at all of your cloud infrastructure, all of the different resources and services. So from like, for example, step functions to ECS services, where you can look at the metrics and the alarms and the insights. Sorry, I don't know why this is taking so long to load. This isn't this is the beta part of our deployment. And like when we take functions, for example, you get like one view of all of the failures, the cold starts, the duration and memory usage. But you can also dive deep into the invocations themselves. So you can look at the logs and the metrics and everything associated with any event in your system. So if you use X-ray, then automatically the tracing would show up here, and you would see where the request started from, what was the payload, and where it kind of went on all the way through the stack. There's also like grouping by microservices. So like how do you look at a specific microservice, not just the collection of functions, but actually the APIs, the queues, the databases, all in one view, and like what's the cost of that? We can see here the cost is quite low. Here are a couple of failures that have happened in the last I think 24 hours, and all of the things that you should be kind of thinking about, like maybe you should enable detailed monitoring for your API gateway, or maybe you should enable logging if you want to debug the requests later. Maybe you want to enable continuous backups for your DynamoDB, along with kind of, hey, actually your application is failing in a quite serious way. It's maybe timing out, or some requests cannot be completed. There's also the ability to search all of the logs across the service. So this is actually powered by Elasticsearch, and you can actually build complex queries. You can interrogate different parts of your system, so different microservices, or all of the function or a specific function, and look at the logs associated with each request. So this was kind of the observability part The second part is the events part. So as I mentioned before, every kind of negative event in your system gets logged, and we find and analyze them. So you can see all of the timeouts and when they started happening, messages or like whatever node exception that you have, or if you're using Java or Python or .NET, everything gets detected automatically. And actually the same goes for metrics as well. So it can be that you're looking at alarms, which are metrics, like, hey, you have low memory usage in your functions, or you have a dead letter queue that's filling up in your SQS. So those kinds of things. And then the last part is the well-architected lens. As I mentioned before, here you can see the evaluation by the pillars. So the security pillar, the reliability pillar, the performance efficiency. So all of the checks we've run, and how many of them are okay, how many are critical, and have warnings or information level events. You can also look at them by region or by services. So looks like the most problematic service that we have is Lambda. Next is API Gateway and SQS queues. And you can go into like, okay, I don't have detailed monitoring enabled for some parts of my system, or I have some functions that are enabled or abandoned. So I can, go back and actually fix all of those issues quite quickly, actually. And if you combine all of that, then it should give you this kind of end-to-end solution to really, build the best serverless applications that you can. So this was the end of my presentation. I'm happy to take questions, obviously. But if not, I would hand it back to the organizers.
Thanks, Taavi. 혹시 대시보드 지금 이제 타비가 발표해 주신 내용에서 궁금한 거 있으시면은 타입해 주셔도 좋고요. 그 마이크 켜시고 말씀해 주셔도 좋고 합니다. 그럼 제가 이제 타비한테 전달을 할게요. So I asked the participant to ask any questions if they have anything.
Okay, so I think there's the first question as well. We have a plan to expand your services beyond AWS? So yeah, actually we do. Azure would be the next. We believe that they have a really good serverless offering, and we can definitely bring value. I think Google Cloud as well, but for us the next kind of priority would be Azure. Awesome. So I guess that's it from my part. Thank you so much for listening. It was an honor to be here, and hopefully we can do this again.
Thanks, Taavi.
Thank you.
Yeah, see you next time.
See you.